Chapter 3. The Breakthrough Year. The year 1905 was a turning point in Albert Einstein's life. It was the year when he published 4 scientific papers that would change the world of physics forever. This year is often called Albert's Annus Mirabilis, or Miracle Year, because of these papers. The first paper was about the size of molecules and how they move. This is a topic in a field of physics called statistical mechanics. Albert used a simple but powerful idea to calculate the size of molecules. He also explained a phenomenon called Brownian motion, which is the random movement of tiny particles in a fluid. This paper was important because it provided strong evidence for the existence of molecules, something that was not fully accepted at that time. The second paper was about the photoelectric effect. Albert proposed that light is made of small packets of energy called quanta, or photons. He showed that this idea could explain the photoelectric effect perfectly. This paper was revolutionary because it suggested a new way of thinking about light. It was a major contribution to the development of quantum mechanics, a new field of physics. The third paper was about the special theory of relativity. This theory changed the way we understand space and time. It said that space and time are not separate, but connected into a space-time. It also said that the laws of physics are the same for everyone, no matter how they move. This theory was groundbreaking because it challenged the traditional views of space and time. The fourth paper was an extension of the special theory of relativity. It introduced the famous equation E equals mc squared, which says that energy, E, can be converted into mass, m, and vice versa. This equation revealed a deep connection between energy and mass, and it has important implications for many areas of physics. These papers made Albert famous. They showed that he was not just a patent examiner, but a brilliant physicist. They opened new doors for him, allowing him to leave the patent office and become a professor. They also sparked a lot of debate and discussion, changing the direction of physics for years to come. In the next part, we will learn about Albert's life after the Annus Mirabilis. We will see how he dealt with his new fame and how he continued to make important contributions to physics. Part 2. One of the most significant papers Albert Einstein published in his Miracle Year of 1905 was on the special theory of relativity. This theory was a revolutionary new way of understanding the basic principles of physics. Before Albert's theory, scientists thought that time and space were fixed and absolute. This means that they believed time passed at the same rate for everyone, and that space was the same everywhere. But Albert thought differently. In his special theory of relativity, Albert proposed that space and time are not absolute, but relative. This means that they can change depending on how you move. If you move very fast, close to the speed of light, time can slow down for you, and space can become shorter. This idea was very strange, but it made sense mathematically. Another important part of the special theory of relativity is the idea that the speed of light is always the same. No matter how fast you are moving, light will always travel at the same speed. This was a radical idea, but it explained many experiments and observations. The special theory of relativity was a big shock for the scientific community. It challenged the traditional views of physics. It was difficult to understand and even more difficult to accept, but it was also fascinating and inspiring. It opened up a whole new world of possibilities. The impact of the special theory of relativity was huge. It changed the way scientists think about space and time. It led to many new discoveries and technologies. It also raised many new questions, some of which are still being studied today. One of the most famous results of the special theory of relativity is the equation E equals mc squared. This equation says that energy, E, can be converted into mass, m, and vice versa. It reveals a deep connection between energy and mass, two concepts that were thought to be completely separate. This equation has many important implications, from nuclear power to black holes. In the next part, we will learn about the general theory of relativity, which is an extension of the special theory. We will see how Albert took his ideas to the next level and how he predicted some of the most amazing phenomena in the universe. Part 3. Another remarkable paper that Albert Einstein wrote in his miracle year of 1905 was about the photoelectric effect. This effect is a phenomenon where light can make electrons move. It happens when light shines on a metal surface, causing the metal to emit electrons. For many years, scientists had been trying to explain this effect, but they were not successful. They were using the classical theory of light, which says that light is a wave. According to this theory, if the light is very bright, it should be able to make the electrons move, no matter what its color is. But the experiments showed something different. They showed that the color of the light is important. If the light is not the right color, it cannot make the electrons move, no matter how bright it is. Albert found a way to solve this puzzle. He suggested a new idea, that light is not just a wave, but also a particle. He proposed that light is made of small packets of energy, which he called quanta, or photons. Each photon has a certain amount of energy, which depends on the color of the light. To make the electrons move, the photons need to have enough energy. If they don't have enough energy, they cannot make the electrons move, no matter how many photons there are. This idea was very bold and very revolutionary. It challenged the classical theory of light, which had been accepted for many years. But it explained the photoelectric effect perfectly. It matched the experiments exactly. Albert's explanation of the photoelectric effect was a major contribution to the development of quantum mechanics, a new field of physics. Quantum mechanics deals with the behavior of very small particles, like electrons and photons. It is one of the most successful theories in physics, explaining many phenomena that other theories cannot. For his work on the photoelectric effect, Albert received the Nobel Prize in Physics in 1921. This is one of the highest honors a scientist can receive. It was a recognition of Albert's brilliant ideas and his impact on physics. In the next chapter, we will learn about Albert's life after the miracle year. We will see how he continued to make important contributions to physics and how he used his fame to stand up for peace and justice.